Let me show you how this is done. For titration method, the rule is your cation will join together with OH minus. I know it doesn't make sense to you. Later, I will show you what I mean, so you can copy down first. The anion will join together with a H plus. So I use NaCl as an example here so that you can derive the starting material. Remember, this is the salt. My job here is to find out my original starting material. So I need to think backwards. You see, this is the double arrow. It's like thinking backwards. So this is thinking backwards here. So you have a Na here. Na, is it the cation? Yes, cation join with OH minus. So your starting material is NaOH. See how it works? You see, this is the anion. Cl is an anion. Anion join with who? H plus. HCl. Can I know the state symbols of NaOH? Of course, because it's a soluble salt. And HCl is a soluble salt. How do I know it? Your solubility table. So is this a good to go to use titration? Yes, because soluble plus soluble to give you soluble, it fulfills all the criteria. Get the meaning? Huh? All right, now let me show you another one. What happened? The method is not so perfect. Okay, we need to troubleshoot a bit. Give you an example. I want to prepare MgCl2. So first of all, you want to prepare MgCl2, you must form an opinion first. Is this a soluble or insoluble salt? So based on your memory of your solubility table, it must be soluble salt. And do you remember the rule I said before? If it's a soluble salt, which one will you choose first? Titration first. Titration fail, then you go filtrations. So I'm going to shift this down a little bit. I just shift it down. You still got space one. So shift this down a bit. So I like to think in terms of titration first. See whether titration will work or not. So I think of titration. Now what is the rule for titration? Your Mg, which is the cation, must tag along with OH minus. So I'm going to write down. Okay, so titration, I'll be using MgOH2. Your Cl is right here. It must tag along with H plus. So it's HCl. Can you see that? MgOH2 and HCl. I need to verify whether titration will work or not. So I need to check the state symbols on my salt. So the state symbols for MgOH2, according to OH, is only sodium, potassium, calcium, ammonia, and barium. Remember the Singapore cat is soluble. This is insoluble, the outlier. HCl is aqueous. So this is not soluble and soluble anymore. It's insoluble and soluble. Therefore, too bad, I cannot use titration. So this is where the method failed. But if the method failed, don't worry. After titration, if it failed, you will go to add in excess. Now, add in excess, we need to use a different strategy. Your cation will bond to a different thing. So if your titration failed, cation will be bond to who? Like I say, this is a strategy. Cation bond to carbonate. There are many methods to do it, but I'll be using this method. It's proven to work very high percentage. Cation, carbonate. Then your anion remain unchanged, H plus. So let's see whether it works right now. So I use a different color ink. I'm going to use add in excess. So your matter will bond with carbonate. Your acid remain as HCl, of course. Now, is magnesium carbonate soluble or insoluble? I think it's insoluble because carbonate only sodium, potassium, ammonia is soluble. This is insoluble. HCl is aqueous. Does it give me my MgCl2 aqueous if you think about the chemical reaction? Yes. Does this fulfill the criteria of insoluble plus soluble to give insoluble salt? Yes, it fulfills the criteria. So therefore, I would say this method will work. So which means that in summary, if you want to prepare a soluble salt, check this one first. The only time it fails is because of the reactant you choose is not the desired version. Like for example, these two are equals, perfect, you can use titration. But if you've chosen the titration, one of them is solid, no, you cannot do titration. Then you use any excess. One of them will work. Let's take a look at the last one. Precipitation. So precipitation, what you need to do the changes. Your cation will be bond with nitrate. Like I said, this is a strategy. There are many methods to work on it, but I realize this is the best method so far. Your anion will bond with K plus or Na plus, either one of them. So this is like a strategy, K plus or Na plus. I give you an example. This is a classic example like silver chloride. Now, silver chloride, they ask you to prepare it. So you must first of all think through, is it soluble or insoluble? Insoluble, because based on my solubility table, I can deduce it. One is insoluble, then I can deduce, okay, this is likely precipitation method. So for precipitation method, my cation will join with my nitrate. So I'll be using silver nitrate. Then your Cl will join together with potassium or sodium. I will choose potassium. You can choose sodium, up to you, right?